Hello, everybody again. My name is Alexey, just for your friends, Alex. It's simpler, it's really easy. And now it's time to talk about really advanced malware and make a deep dive into its investigation. As usual, a few words about me. I'm a senior specialist at Expert Security Center of company Positive Technologies. Some years ago, I worked as a malware analyst and well-known antivirus vendor in Russia. Now, my duties are threat analysis, reverse engineering, tracking of APT groups, and searching for new gangs. Here is a plan of our journey. It will be a technical, hardcore research, so be patient. Be brave. We'll begin with a brief discussion of features TA505 group. Then I will show how our sample is packed. Then will be a few words about preparation stage. We'll learn how it will achieve persistence on system and invoke a payload. We'll finish threat analysis part with network interaction, and after that I'll resume everything said and give a few tips for blue teamers. So let's begin. One of famous gangs is TA505. They were known since 2014. For this period of time, they targeted approximately half of the world, and there are several well-known malware families such as Dridex, Banker, Locky ransomware. Actually, they have not ever stopped developing of new tools. That's why there are some fresh samples such as backdoor float grace, self-helper rat, tiny meter prettier, custom email stereo, so about dozens of different samples. One more interesting thing that this group sometimes intersect with others. For example, we know a case when TA505 and another gang which calls Bootstrap used the same network infrastructure. Another case was with financially motivated Silence group. Silence used a portable executable packer of TA505 group. It's really interesting. By the way, I think the most part of victims of these groups are just simple users, home users. On the other hand, cases when they targeted some enterprise sectors, such as financials, manufacturers, healthcare, education, even government entities. They have different malware family tools. Some of them are really simple, but some of them complex. And in this case, some attacks can be recognized as really advanced. That's why I can say that this group sometimes APT actor. So, during regular investigation of samples, of new samples, which are related to TA505, I found one portable executable for 32-bit platform. You see some common characteristics of it. It was interesting that I have not seen such sample before, so started investigation. One more common feature, this sample is signed. Actually, the timestamp after compilation is forged, but we have another time in digital sign, and this is an approximate time when this campaign was active. It's about September of previous year. So this sample is consequently packed with two different packets. I will briefly describe both of them. The first one begins with a couple of arithmetic operations. Basically, they do nothing. It's just a well-known technique how to break some portable executable emulators. Then a first layer will be decoded. This is a simple routine based on subtraction, exclusive OR, shifting operations. Please remember this. We'll return to it later. Then the execution flow will be transferred to this first stage, and one pointer will be transferred as an argument. It's a pointer to a structure. It has several fields and a handle to kernel 32 library. Please remember this handle. I will tell a few more words about it later. Then it will be a pointer to an encoded buffer and the size of the buffer. Then it will be some kind of magic. It will be used just on the next slide. And finally, size of decrypted data. I hope that some of you, maybe a major part of audience, are reverse engineers or just tried such activity. If you open a file in a hexadecimal editor, you will see some picture like that with bytes with 0 bytes and with not 0 bytes. And if you investigate 10, maybe 20 such samples, in some moment you will be easily recognize this picture in an editor, and it will be a good indicator that, oh, okay, yes, this file is packed with this packer, and I know everything about that. So after transferring a code execution, a few more decoding routines will be. The first is some kind of reduction. You will leave only 3 bytes from each 5. And after that, again, the same routine. You have already seen it. And here is a special value, block magic. We have transferred it in a structure before executing this stage. After that, we'll invoke a big function with plenty of arithmetic operations. The easiest way is just to find several unusual values, search them in an internet, and you'll have a success. You'll find a well-known compression, decompression algorithm which calls APT. Let me stop and remind that there is portable executable packer which calls FSG. Actually, does anybody heard about FSG? Please raise your hands. Looks like you have heard, but can't remember. This packer is used in APT decompression compression too. Actually, there is a small difference. In case of FSG, our file will be compressed by sections. In our case, the whole file is compressed. One more small off topic. After everything has been made, our sample will make some few tricks. It will find a process environment block, locate self-image, we'll find an entry point. As you know, all executables have an entry point, and we'll just rewrite this value in environment block. It's cool. No questions. We need to do that because we have unpacked a new file, but I hope you remember that we transferred a kernel 32 handle by a few steps before that. Another question is why we need it, because we can locate a kernel 32 via process environment block 2. We can find this handle, and we actually don't need to transfer it as a parameter. I can imagine that a threat actor didn't know about that, but now we see that it uses pip. So why it needed, I don't know. It's an open question. Okay, that was the first one. And before we will discuss second packer, one moment, file on this stage have a debug information. This is a full path of C project, and we can extract many information from it. For example, we see the name of this file with something like dropper on C language, and this is only part of a bigger project. It calls malware 41. Maybe it's some order of authors projects. And I've used this substring in a title of presentation. Another one string is about DNS. Okay, maybe we'll have some kind of DNS protocol in some moment. Now we can just remember it. By the way, this is the beginning of the second packer. It's pretty easy and straightforward. It's a linear XOR algorithm, but with interesting feature. Please look at the call of net validate name Windows API function. It will be invoked with wrong arguments. This Y, the error code, will be 35 in hexadecimal form. After that, we will subtract another value from it, and finally receive a 4. A 4 is a step which will be used during XOR routine. So can you come up with a better approach how we can construct the value 4? Actually, an actor decided to do something like that. Then our data will be transferred to another one function. An RTL decompressed buffer with an argument, with a special argument, will make a LZNT1 decompression routine. And if you look at the data before decompression, we can see some strings just at the bottom of the slide, which helps us understand that yes, that is another one portable executable file under that. That's all. That was unpacking the routine, and now it's time to discuss the preparation stage of our malware. A few characteristics. It has a hard-coded self-name, some kind of payload loader on 32-bit platform, maybe something like that. It's a DLL library. It has one exported function. Everything it does is just parse a portable executable header, tries to find a relocation table, and then just use it to fix hard-coded offsets with a new base address. So some relocation purposes. Then we will find a couple of if-else instructions. We see an address which is always at the bottom of the address space layout of our sample. This is a k-user shared data structure, which contains several useful fields. We can address to a geof-chapel purpose, and now we see what these fields mean. Actually, it's a product type, build number, major minor versions. Basically, it's an approach how we can determine an operation system version based on information in k-user shared data structure. I can say that it's not so well-known, not so used approach how we can do that. Well, we have recognized the operation system version, and this is not the end. We'll use these values to find an exact offset in a big array of predefined bytes. These bytes are offsets of several functions in kernel structure, which calls service descriptor table. One more off topic. We can get our anti-DLL library from just our Windows operation system, disassemble it, and find some exported function, find the beginning of it, and we'll see that some constant value will always be moved to EAX register, and after a few steps, a kernel call will be made. This value is exactly then an offset of function in kernel service descriptor table. So a malware will determine 16 values. In my virtual environment, we have such bytes and corresponding anti-functions. As you see, these are the most important functions which you can use later. So if you have a 32-bit platform, we'll use a fast syscall. In case of 64-bit operation system, we will make the kernel call via sysenter instruction. Just to relax you a bit, one more off topic. The most interesting moment during reverse engineering is to understand the way of thinking of a threat actor, and another moment to find some interesting and unusual details and pay attention to them. And this is a simple example. We see that some system path is constructed. In the first case, is system32 substring is appended to some another one string, but in case if you have 32-bit platform, an author decided just to get only 5 last symbols and just replace them byte by byte to some another new value. In this case, we have a syswof64 substring, and a question why we cannot just save 2 substrings and switch between them in case of different platforms. Okay, the quality is in details. After that, Yeah, we have 16 most important functions. Now we can find necessary libraries and just read them. After that, we can parse a peer header of these libraries, locate and export table, enumerate all function names, and for each name, we can calculate a hash. Actually, this is a simple algorithm. How we can get a hash, it's just 4-byte value. Well, based on hash values, we can compare our value with predefined array of some hash values which are hard-coded in our sample. And based on comparing, we can realize that, yeah, we have found the necessary function, and now we are ready to execute it. On this moment, it's very useful to write a helpful Python script for our interactive disassemble. We know everything, so we are listing the libraries. We know count of functions. We know address of hard-coded array of hashes, a new place where resolved addresses of functions will be. So we just repeat these steps. And finally, we can rename these labels in our listing. Good. Now we resolved all API functions which will be used by our sample. And this is not the end of preparation step. After that, a long and complicated part where our sample tries to check if its self-process name is blacklisted. It will extract volume information and we will use it as a victim identifier later. It will enumerate all processes via anti-query system information API, and then it will check, are we under virtual environment or have some antivirus product installed in our system. One more interesting trick, it will find its self-body, then it will compress it via Z21 compression routine, encode it via XOR, prepend a few necessary values such as XOR gamma at the beginning, and you'll save a pointer to this data. I will show you the moment when it will be used. Finally, we need to miss some steps because we have not enough time, but this is the final structure. After reconnaissance step, we see that our sample gathered plenty of necessary information such as privileges, integrity level, situation with blacklists. Actually, I want to specify that this is not only true or false. Blacklist values are some digits like 1, 3, 6, some kind of level of dangerous. This environment is so bad for us or not. Okay, and based on this structure, we can continue our actions, and this is a persistent stage. I will show you how sample will achieve this important moment. Firstly, I need to say that we have a hard-coded shellcode, and this shellcode will be extracted and appended with a few important information, such as some addresses of NT functions and registry branch. You can see it on the slide at the bottom. So at the beginning is the shellcode, and at the bottom are the information. You can see that the end of branch is some unique global unique identifier. It will be generated based on reconnaissance information. And what after that? Our shellcode will receive an execution. It will read data from registry branch. Then it will decode it. Now you can understand that it's the same decoding routine, linear XORing. After that, decompression with the Z21 algorithm, and this shellcode will be invoked. What's the purpose? When we have this intermediate step, let's see the full picture. In some moment, malware will find victim process and will begin to make some kind of process injection. It will open the process, prepare thread structure, suspended process, and in this moment, a magic will be. Thanks for the previous talk, we can find some relations with it. Actually, our sample has a hard-coded sequence of bytes. Then it will try to find these bytes in NT DLL library. As we see, it's the end of, I can say, several exported functions. And based on the instructions, return, pop, pop, and many of you know this yet another one, returns-oriented programming gadget. We saw some more interesting sequence in previous talk. In this case, situation simpler. So what will be after that? Our sample has a pointer to this sequence of bytes. It has an address of them. Now we can rewrite an instruction pointer register in our thread context of suspended process. And after that, the thread will be resumed. And we performed injection of our shell code in some victim process with the help of ROP gadget. As for me, it's a nice trick. Another way, what can we do? Malware will create a partial script. You can see it at the bottom. At the beginning, I have truncated a sequence of bytes. It's the same shell code as we discussed previously. The partial script will be created and drop in the system. Full path is actually hard-coded too. I just need to say that about partial script, all variables, namespaces, options, functions, arguments, everything is not just hard-coded. All parts of partial script are generated on the fly. In some moments, for example, variables are randomized. Some actions are obfuscated a bit. That's why partial script always different. In another case, we will not drop partial script on the system. We will generate an intermediate launcher. We will encode our previously made partial script via base64 algorithm, and then we'll start to create a JScript on the system. We will find an application data path. Then we will find a special branch in system registry, which is responsible for installed software in the system. When we have a list of installed software, we can choose any name, and in my virtual environment case, that was address book name. And after that, we are ready to create a JScript with this name, so it looks like an installed software. We can make a few steps to wrap our partial execution into JScript language. And that's all. We will create a JScript, but with interesting option. I hope somebody knows what a MAC abbreviation means. And no, it's not about media access control and network. This is modified, accessed, and created timestamps. Digital forensic experts know about that. What actually will be happened before creating a script? Our sample will read an NTDLL library properties, will extract these timestamps values and just assign these timestamps to our script. This technique is called timestamping. As a result, during forensic investigation, during the timeline creating process, our script will be relatively old, and for some time it will be invisible and maybe hidden from a not experienced investigator. This is how actually this sample is looked like finally. And the final question is, who will actually execute it? Yeah, cool, we created a script, but where is execution? Our sample will abuse Windows scheduler, and via COM interfaces we'll create a task. And interesting that this is a big function of plenty of code. It contains and uses several COM interfaces, and all options are carefully filled. You can see that even option related to batteries, for seems that for laptops, will be not forgotten. Cool. And after this huge amount of actions, yet another one PowerShell script, which will be launched and delete or clean event logs, which will be created in the system. Again, yet another one action against forensic experts for a future investigation. That's all. That was only a persistent step, but I hope you remember the title of our talk, and we are analyzing some kind of Trojan downloader. Where is the payload? How to be invoked? This part about that. So we have already seen that in some moment global identifiers will be used. This moment is the same. We'll generate some another one identifier based on reconnaissance information, and we will use this value as a file mapping object to open and extract some data. Then there are a few ways again. The first is quite straightforward. We'll use this data as a one more portable executable file. We will fix a header a bit, save to the system, and invoke it via run DLL32 process. So quite easy, quite simple. Seems that is the case when this is not a virtual environment. We have no any antivirus solutions. Well, another case, a bit complicated. We'll start in suspended mode an MCI exec process, some legitimate tool, you know about it. And then familiar action will get a thread context and just will write instruction pointer value to an exported address of our DLL, new payload DLL. And finally, a thread will be resumed again. Quite simple, but there is another case which is more sophisticated, and let me discuss it in detail. Basically, we will show that we are trying to find and load a Windows Update client library via load library instruction, load library function. So looks like not suspicious, but in this case, several anti-functions will be changed. How it will be? We will find beginning or prologue of these functions. I hope you remember that some important functions in Windows libraries are prepended with NOP instructions or some kind of do nothing operations. These values will be changed with jump operation and some address. And at the moment when we will invoke a load library function, a hooked functions will be used instead of these anti-legitimate ones. And this is how a payload will be loaded and invoked, and everything will be looked like we do some legitimate action. After that, of course, all changed values will be rewritten for the previous values as it was before our action. So, and after suspicious loading, everything will be clear again. And here are a few examples of function which will receive an execution flow after hooking. Without going in details, they are just loading and invoke our payload. Cool. And the last moment is related to network, to a command and control server interaction. Our malware has one more data inside it, one more portable executable file, which is XORed with a 24-byte key. After decoding and decompression, as you see again, it will be loaded via hook and splicing procedure, as we saw on previous slides. So this is only one sample in this chain, which has not forged timestamp value in header. One more indicator of previously mentioned approximate time when campaign was active. So this plugin, we will name it plugin, contains a configuration, some magic value at the beginning, then sequence of bytes, which is RC4K, a size of remaining data, and just encrypted data with RC4 algorithm. So we can use this key and decrypt it, and we have an HTML style string. The most important values for us, just as you see, IP address, CNC address for our future communication, and just new one, RC4K, which will be used to encrypt and decrypt communication between our plugin and server. So actually, this plugin has two exported functions, to send and to receive data. And during this process, encrypted data will be encoded via base64 algorithm, but not only just that. This algorithm customizes the bit. Several symbols, you see, plus sign, slash, will be replaced to another sequence of bytes. By the way, you see that it happens randomly. After that, if you have a huge buffer, we can divide it into chunks. Then each chunk will be split by dots. So maybe some of you understand what is happening now. After that, our data will be, let's say, signed via MD5 hashing, and this value will be encoded with base64 and appended to buffer. And last step, we need to generate some kind of domain name. Top level domain will always be .com. It's good. And a few more symbols. Two of them are always letters, and remaining two are just digits. So during communication, all requests and responses will be with special header. We'll call it header packet structure. Here are values. The first one is some random value. It will be generated with such algorithm. The second field is some sequence, something like sequence number. I hope everybody are familiar with TCP transport protocol. So you can imagine that this sequence number is something the same. Then you have a third value. It's always zero. Not always, but usually zero. In some cases, some other value. I don't know actually why it needed, but we can call it zero. Then we will store volume information number and we will append it to this structure. As you remember, it's some kind of victim identifier for us. Then yet another value will be XOR2. This is something related to chunks. It can be an amount of them, or it can be a particular value of some kind of order of chunks. We have several chunks, and we need to reconstruct our payload correctly. And final value is just the same as first. So now we are ready to look at an example. Here is the opened traffic dump in Wireshark software. Now we see how it looks like finally. It's some sequence of requests under DNS high-level protocol. But an interesting feature is the type of communication is X25. Actually, does anybody use or does anybody know about this type of request? I'm not sure that it's very used or well-known type. It's relatively old, and it has been made for experimental purposes. In our case, we have some DNS tunneling procedure during network CNC communication, and it's happened under X25 DNS requests. I just want to show you a few examples. You can get one session. Actually, a domain name, last 7 symbols will be the same because it's only one session. We see first request and first response, and the most important value for us is the number of chunks. Then this is a first chunk. It's a huge host name. A major part of it is a payload, then a header structure, and finally a domain name. So the same will be with other chunks. So just imagine that we have 5 more of them. Finally, we can get the data, just join. After that, we can perform a base64 decoding with custom feature. Then we'll use an RC4 to decrypt data, and we have something like transferring of reconnaissance information of our sample. And a few more packets. You see that payload is the same. Basically, it's an MD5 hash of our previously sent data. Why 2 packets? I don't know, but it's some useful indicator for us. Another example, we have a payload in response from our server. We can split it by special sequence of symbols. Structure is not interesting, header structure is not interesting for us, but we can decode payload with the same algorithm. And finally, we have HTML-styled string again. In this case, it's the same as it was, as we have already seen. Some kind of configuration for future requests here is not changed. And of course, this data will be signed with MD5 too, and everything will be correct. Well, that was about threat analysis and a few attribution moments. At September of previous year, at the end of September, we saw a notification in Twitter about some another similar sample. Now you can see many familiar strings based on this talk. After a few weeks, Proofpoint researchers published an article where they describe a new campaign of TA505 group. They mention several malware families, and one of them is Snatch, or some kind of Snatch loader. You actually can find an information related to the old versions of Snatch loader, and we can find such script on GitHub, Python script. We see a function, some generate K routine. Based on some interesting values, I can say that our sample contains exactly the same algorithm. I have not described it, but it's about login and login encryption. So, by the way, the algorithm is absolutely the same values, the same formatting string for future printing. So, seems that we have some kind of reborn, some kind of new version of Snatch loader Trojan. And now I'm ready to resume something and give you a few tips, useful tips. I know that many of you are red teamers, but create a good malware is a nice thing for red teamers, by the way. So what we saw, first of all, tasks. And it's not the first case when actors use tasks. Okay, we don't forget about that. Abusing of PowerShell and W scripts or creating such scripts on the system is always suspicious, and everybody know about that, and it's just one more reminder for that. There are not so much cases when an MCI exec process will be created with legitimate purpose. Then process suspending is quite suspicious operation too. We saw an old trick which calls splicing. Very old trick, but it's still in use, it's still live. So yeah, it's clear that we need to make some kind of integrity control of our system libraries and always check that nothing has been changed. Well, hope that many security solutions check that. A few more moments, we saw using of ROP gadget, something like ROP gadget chain. It was very simple, but yes, usually it relates to vulnerability exploitations, but commonly this is a really complex technique. Sometimes it can be detected, but these cases are so customized. So commonly it's a problem, and we still need to find a really cool solution how to defend from it. Then again, something about DNS tunneling, but in this case with unusual request type. What should we know? Yes, we know that we need to monitor not only well-known and not only widely used request types, we need to monitor everything. And if we have some unusual type, we should look at it properly. So, everything was just only about a Trojan downloader. It's not a RED, it's not banker or some kind of steal, it's just only a loader. And this is some kind of trend nowadays to create persistent and complex, but very light malicious samples. Many groups are familiar with that. Fancy Bears, APT 29, Emissary Panda. Actually, it's very effective, and we just should know about that. And finally, my opinion for such situations, many researchers, as for me, confuse APT with targeted attacks. Yes, there are really cool groups which attacks quite interesting entities. They have quite difficult goals. We remember something like Project Sauron or Duco 2, or Equation Group Toolkit, of course. But there are several groups like TA505. As I said, the major part of victims are just home users. By the way, sometimes they can attack important entities, and they can use, and they still use sometimes, but they still use complex malware. And that's why, as for me, APT is not the same as targeted attack. That's all. And if I have final minutes, I just want to thank organizers for invitation. It's my second time in India and in Goa. I really love that. I'm happy to be here again, and thank you for your patience. That's all. Thank you.
Anyone have questions? Yeah, please.
So basically there was a slide where you show that RC4 was actually used, and all I could see was just a sequence of hex bytes. So how do you identify that, this is for RC4 and this is a key, and
Sorry, I understood that your question is about RC4
yes.
encryption, but please repeat last part again. What do you mean?
So there was a slide where actually all I could see was a sequence of hex bytes.
Yes.
And you say that this is the RC4 cipher that is used, and this is the RC4 key. And then you actually use that key to decode the actual data. So how do you identify from those hex bytes that this is RC4 cipher, this is a key?
I have not shown you an algorithm. Actually, malware have a sequence of arithmetic operations, and for experienced eye, it's very easy to recognize an RC4 algorithm. A few notes to RC4, as you saw, that the first sequence of bytes is always the same, and it's hard-coded, but in some moment, a malware sample can receive an update from a server. In this case, an encryption scheme will not be changed, but key will be enough, and it depends on victims, and we can't decrypt traffic in general case.
So you're saying that the few bytes of RC4 are actually quite similar, so it's very easy to identify.
A few bytes easy to find.
Basically, you said that it's very, the bytes are hard-coded, and it's, few bytes are actually same. Is that what you're trying to say?
Seems that I can't understand what you mean. Let's talk about that just after my talk will be finished. Sure. We will discuss it in details. Maybe it requires some more time.
Thank you.
Any other have questions?
Yeah, hi. First of all, good
Hi.
talk. So thank you for that. My question really is this malware you mentioned
Please a
about.
bit louder, a bit louder.
Okay. My question really is you mentioned this malware being used in TA505 and Duda, whatever it is called, but do you think it might still be used in Bootstrap? Like how Bootstrap moved from targeting financial group to the government groups in 2019? And do you think this, because it's as a dropper and Bootstrap also uses NSYS and then goes to a grabber? So have you seen any similar in your Intel or in your actor attribution? Have you seen anything similar to that? And also when you spoke about the evasion, the defense evasion, you mentioned about time stomping. So if I'm monitoring time stomping via PowerShell, could this be gathered?
Sorry, it's very fast for me as I'm not a good speaker in English. I will ask you to repeat your question after that with a bit slower tempo,
Yeah, definitely.
and I will answer to you.
Definitely.
Sorry. By the way, everybody who have some questions, please come to me directly. It will be more effectively, and I will answer for all your questions one by one. Thank you.
Thank you, sir. Having a tea break.